So today we're going to start talking about solving quadratic equations by formula. For the last couple days we've been talking about solving quadratic equations in general. We solved quadratic equations by graphing. Yes, graphing. We solved quadratic equations by factoring. Solving quadratic equations by graphing is really great to use when the graph crosses right at two whole numbers. Otherwise, it's just a guess. Okay? Factoring is really great when you have a trinomial that factors really easy. They're much easier than the quadratic formula when they work. But what happens when they don't work? What happens when it doesn't cross right at two whole numbers on the x-axis? What happens if you can't factor or it's a difficult factor problem? Solving the quadratic equation using the quadratic formula works every time. Okay? So why don't I just teach you this exclusively and don't teach you anything else? There's more than one way, first of all, and it's not always the easiest. Like I said, if it's a factorable equation, so much faster to factor it and get your answers. Okay? But quadratic equation, solving quadratics using the quadratic formula does work every time. Okay? So first thing I want to do today is teach you the quadratic formula. And the reason I want to teach you this is a lot of times I don't make you memorize formulas, do I? I say, okay, you really need to know this formula, but when it comes right down to it, I usually let you use your notes on tests, don't I? Okay? Quadratic formula is one of those things I think is really important because of the fact that it works every time, because of the fact that you use quadratics in different math classes. Okay? Guys, I've used the quadratic formula when I've been working on my master's degree. When I was taking calculus and we had to solve a quadratic, I had to use the quadratic formula. Okay? It's not just something we use in this class and then it's done and over with. Right? This is something that reoccurs in different math classes above my class. Okay? So here's what the quadratic formula looks like, because you can see that so clearly on the screen. It's also written on the board in black beside the screen. Okay? But this is what the quadratic formula looks like, and this is how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now everyone knows the tune, because the tune is Pop Goes the Weasel, right? Pop Goes the Weasel. Excellent. So now that you know the tune and now that you know the words, because they're right here, please sing it with me. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's a problem. There's a problem. What is this for? It doesn't do you any good to know a really cool song if you don't know what it's for. What is this for? To solve a quadratic equation. How does it start? X equals. I'm solving for x. Okay? So it's great that you know this really cool song now. And unfortunately, it's probably going to get stuck in your head over the next couple days. Blame me. I don't care. All right? But I need you to make sure to know what it's used for, how to use it, things like that. Okay? But before we can even get there, we got to go backwards a little bit. Okay? We got to go back to some stuff on this sheet. The first thing I want to go back to is right here. I is the number you can square to get an answer of -1. If that's the English, what does the math look like? I is the number you can square to get an answer of -1. Could you translate that English into that math? Okay. What's the second sentence translate to? I is the square root of -1. I is the square root of -1. Where the heck did I come from? Well, Imaginary. I stands for imaginary. Okay? Yes, ma'am. What number? I is always the square root of -1. I squared is always equal to -1. Okay? Can you even tell that this is almost in steps? This step can go to this step? How would I get from this step to this step? Square root both sides, right? If I square root this side, I get I. If I square root this side, I just get the square root of that side. Okay? These are two pretty important things we're going to talk quite a bit about today. All right? So go with me here for just a second. I need you to be able to manipulate numbers like this. For instance, the square root of -49. Could you tell me the answer if the problem was just the square root of 49? What is it? 7? But it's not just 49, it's -49. Or 7i. Because the square root of 49 is 7 and the square root of -1 is I. Yes? So what's the square root of -121? 11i. So what's the square root of 17 minus 42? Well, what is 17 minus 42? 25, so it's the square root of -25. 5i. Okay? So let me take you back here just a second so you understand what's happening. Because we've just kind of gone here. Let me make sure you understand the math behind it. According to the properties of square roots, I can say this is the same as -1 times 49, right? And because of the properties of square roots, I can say the square root of -1 times the square root of 49. That's how we can get to 7i, correct? Does that make sense? So then what do I do when I get to a problem like this? It does separate into the square root of 1 times the square root of 3, right? What is the square root of -1? I. What's the square root of 3? I don't know either. Okay? So what about E? Anybody know what the square root of -36 is? 6i. So I end up with 12 plus 6i over 2. Can you say 12 plus 6i is 18i? Why not? It's not the same thing, okay? That's a good way to put it. Can I fix your words real quick? I know that you understand what you're talking about, okay? If you look back up to the directions, I know it seems like we're going out of order, but I promise we're okay, okay? It says simplify the following complex numbers. Does a complex number mean that it's really difficult? It's complex, so it must be difficult, right? Okay, a complex number means it has two different parts. It means it has a real part, like 12, and it has an imaginary part, like 6i. So I can't combine real and imaginary. The only place that ever worked is Who Framed Roger Rabbit, okay? But we're not talking about that right now. Okay? I cannot add 12 and 6i. All right? Just the same as I couldn't add 12 and 6x, right? Can I divide each term by 2? Yes. So how would that simplify? 6 plus 3i. Questions? You good? Okay. I need to talk just a little bit more about complex numbers. A plus or minus bi. A is the real part, bi is the imaginary part. Okay? So first of all, I want you to put these numbers right here into a plus bi form and then identify the real and imaginary parts. So what about f? I need you to put it in the form a plus bi. So that would be 25 plus 0i. Why? It doesn't have an imaginary part, but if it's got to be in this exact form, I've got to put something there, right? Do you guys mind if we use some abbreviations? There's the real part. There's the imaginary part. And I want to use a capital I, because when I have the I for the actual imaginary, it's a lowercase cursive I. It's supposed to be in italics. I can't write in italics. Okay? So what about G? What's the real part? 0. What's the imaginary part? 25i. Okay? Some of you guys are trying to take the square root of it. Okay? Don't do that. It's not asking for that. It's just asking you to put it in the form a plus bi. So what's the real part? The 0. What's the imaginary part? 25i, right? Okay. What about h? Put it in the form a plus bi. It's already in it. What's the real part? 3. What's the imaginary part? What about I? I mean, problem I. Sorry about that. Problem I. Nine plus 12i over 6. Is that where you're stopping? You can divide everything by 3? No? I don't want to. Yeah, I don't want to do that. I suppose you could. Why would it be 4/3? It would be 3/2. Okay. It's okay. So if we simplify everything, the only thing they're all divisible by for sure is 3. So 3 plus 6i over 2. So here's the tricky part. What is the real part? 3 over 2. That's the real part, right? What's the imaginary part? Hey, you guys didn't correct my mistake. Okay, thank you. I just now saw it. What's this supposed to be? 4. I mean, not that it's your job to make sure I'm right. I'm hoping I'm right most of the time, but it's okay. I'm not blaming you. What's the imaginary part? Yeah, it would be 2i, right? It would be 4i over 2. That's the imaginary part. Oh, it looks like a heart. Aw. That's what Jonathan was saying a second ago. Can you have 1.5 plus 2i? And that's fine also. Yeah, that's totally fine. If you did that, this would be the real part, and this would be the imaginary part. I just don't want you to be so afraid of fractions that you never ever deal with them. And honestly, some of you are still there. Okay? You don't have to raise your hand. Okay? Alright, look at J. Problem number J. -4 plus 13i. And how'd you get that? Combine like terms. Combine the real parts, combine the imaginary parts. This is the real part. This is the imaginary part. K. Nathan and I are going to do K. We're going to do K. You ready? We're going to say 6 times 6. Okay? This deals with something we were talking about this morning. That's why I'm singling you out. Not because I'm trying to embarrass you. Because if I was, I totally could. 6 times negative 2i. Okay so far? 2i times 6. 2i times negative 2i. Okay, are you ready for me to blow your mind? The answer is 40. What happens with this middle stuff? That's 0, right? Negative 12i plus 12i, that's 0. What does I squared equal again? Negative 1. What's negative 1 times negative 4? What is 36 plus 4? 40. Interesting. I think that's the nicest thing I've heard all day about this. Yes, absolutely. If on like a test or a quiz it said simplify, that's totally the answer. But because of the directions on this part right here, we would need a 0i. And then we would have the real part and the imaginary part. Good question. Yes, sir. Cursive, really. It's really a cursive I. Unless you want to write in italics. Okay. All right, here's the easiest thing we're going to do all day that sounds like the hardest thing we're going to do all day. I got to teach you how to write a complex conjugate. Anytime it says complex, you automatically think it's hard, right? Because the word complex has a definition of difficult. Okay? But a complex conjugate is really, really not hard to figure out. If one of your conjugates is a plus bi, the other is a minus bi. If one of your conjugates is a minus bi, the other one is a plus bi. What happened to the real part? Stayed exactly the same. What happens to the imaginary parts? They're opposites. So let's start with the hardest one. What happens with the real parts? So what's the conjugate of 25? 25. What happens to the imaginary parts? So what's the conjugate of 25i? Negative 25i. And now they have to throw these in here to try to trick you. Don't be tricked. What happens to the real parts? And what happens to the conjugates? Excuse me, the imaginary part? It's opposite. So what's the conjugate of negative 3 plus 6i? Negative 3 minus 6i. Negative 12 minus 5i? Negative 12 plus 5i. 2/3 minus 1/5 I. See, they even had to make it harder by just putting fractions in, just to freak you out. Real part stays the same. Imaginary part's opposite. Real part stays the same. Imaginary part's opposite. Yes? Okay. So let's see if we can do something with it. Okay? This is a simple quadratic. I'm not saying if you don't get this, you're dumb, because if I meant that, I would say that, but I didn't say that. This is a simple quadratic because there's no x term, right? There's an x squared term, and there is a constant. So how can I solve a question like this, an equation like this? If I get all the x's on one side and all the constants on the other side, right? So if I subtract 96 from both sides, would that work? 6x squared equals negative 96. Divide both sides by 6. X squared equals negative 16. We need to take a commercial break real quick. You ready for a commercial break? Okay. Fundamental theorem of algebra says that if I have a degree of 2, how many solutions should I get? 2, right? We learned that last week. Do you remember that? The fundamental theorem of algebra. Whatever the degree is, that's how many solutions I should get. In a quadratic, it's 2. I should always get 2 solutions. Even if it's a double root, I recognize that it's a double root, right? So if I was solving this, I would take the square root of both sides and I would get what? What's the square root of 25? 5. How many solutions is that? 1. But it has to be 2, doesn't it? It's not a double root. So tell me, what times itself gives me 25? A 5, but what else times itself is 25? And so how we're going to write that is like this. Because that takes both of them and it's less ink. And so we're saving the environment. As long as you realize that it's a positive 5 and a negative 5. Fair enough? Okay, back to the show. We're here. Square root of, x squared equals negative 16. How do I solve that? I take the square root of both sides. What is the square root of negative 16? Plus or minus 4i. That's my favorite one, just so you know. That was my nickname as a child. Yeah, it was. 4i. Yeah, 4 i's. Yeah. Do you see that we also just got complex conjugates? Because one of them is 4i and one of them is negative 4i. Aren't those conjugates? Yes? Yes, ma'am. Uh-huh. No. The I is still I. I doesn't have a sign on it. I is just I. Look back at what we wrote. The I squared is negative 1. I is the square root of negative 1. I doesn't have a sign. So it's a positive 4i and it's a negative 4i. Okay? Usually my name was a negative 4i. It was a negative connotation. But whatever. I'm over it. Okay? We good? Look at number 10. What is the quadratic equation with solutions of plus or minus 7i? So what are we having to do? Work backwards, absolutely. So we're starting with an equation that looks like x equals plus or minus 7i. What's x squared equal to? What is it? 49? Like that? Isn't it negative 49? Because I'd have to take the square root of both sides to get the plus or minus 7i. So is that an acceptable quadratic equation? Not quite, right? Usually our quadratic equations equal 0. So if I was going to add 49 to both sides, whoops, plus 49 equals 0. Pretend that's a plus sign. Is that the only answer? How many answers does this question actually have? A bunch. Because here's one. 98? Right? Yeah, I don't even want to try. I mean, there's tons I could do, right? Any multiples of that, I could add or subtract numbers. I could add 2 here and add 2 here, and then when I subtracted it would still get the same answer. You see what I'm saying? Oh, yeah. This is a perfectly acceptable answer. I'm just letting you know that that's not the only answer, because you know how I feel about that. Okay? You okay with that? Okay. There's a really beautiful chart on the next page. The problem is, what's the problem with this chart? There's so many words. Okay? So many words. Please don't give up on it just because there's a lot of words. Okay? What this chart tells you is about the discriminant. The discriminant is b squared minus 4ac. Have you ever heard that before? Oh wait, it's already part of the quadratic formula? It's the part inside the radical, right? Doesn't include the radical. It's only b squared minus 4ac. And finding, okay, first of all, I have to make this very clear. The word discriminant, which is what this is something completely different from discriminate. I'm not making anyone sit at the back of the room. Okay? All right? That was just a little joke. Okay? This is called a discriminant. I just didn't want there to be any confusion. Okay? This is the discriminant, b squared minus 4ac. Okay? Finding the discriminant will help me a lot. If I find the discriminant and it equals 0, hold on, let me show you something real quick. Dang it. Okay, here's the quadratic formula. If I find the discriminant is 0, what's happening with my answer? What's the square root of 0? 0, so I just end up with negative b over 2a, don't I? How many solutions is that? That's only one solution, isn't it? So that means it is a double root. It's a rational double root. I'm going to get a number that's a double root. When the discriminant equals 0. Okay? When the discriminant is greater than 0, so it is a, how else can I describe that if it's greater than 0? Positive. Okay? If it's greater than 0 and it's a perfect square, for instance, these, plus there's more, what's going to happen when I take the square root of a perfect square? What do I end up with? Don't I just end up with a whole number, an integer answer? So I get a whole number plus or minus a whole number divided by a whole number. That's going to give me 2 rational roots. Okay? While they may not end up as whole number answers, they might be rational, which means fractions. It's still something that I can solve for fairly easily. Yes? So another option is if it's positive, if it's greater than 0, but it's not a squared number, like one of these numbers or many, many more, right? What happens if I take the square root of a number that I don't know the square root of? I get negative b plus or minus the square root of something over 2a. I'm still going to get 2 answers, but I'm going to get 2 irrational roots, numbers that I cannot write as a fraction. Okay? I can't simplify it down to a decimal without rounding it. Does that make sense? Okay? And then the last possibility is if my discriminant is less than 0. Another way to describe that is negative. What's going to happen if I take the square root of a negative number? Yeah, imaginary number. I'm going to get 2 complex roots. It'll have a real part and an imaginary part. Okay? So let me do some problems for you like this, and I think you'll see how this is used. All right? So for each problem, we're going to write the equation in the correct form. ax squared plus bx plus c equals 0. So first I have to add 2 to both sides, right? 3x squared plus 7x plus 2 equals 0. Next, I want to identify what? What am I going to need to use for my discriminant and for my quadratic formula? A, B, and C, right? A is 3, B is 7, C is 2. So finding my discriminant, b squared minus 4ac, well, what's b squared? 49 minus 4 times 3 times 2. What is 4 times 3 times 2? 24. What is 49 minus 24? So tell me what you know about the number 25. It is greater than 0 and a perfect square, so I will have 2 rational roots. And then part C says solve, right? Complete the formula to find the solutions. X equals negative b plus or minus the square root. You guys are pre-AP, so I'm going to skip a step here and just put in 25. Everybody see where I got that? All over 2a. Negative 7 plus or minus 5 over 6. Am I done? No. What is negative 7 plus 5? What is negative 2 divided by 6? Negative 1/3, a rational number. What is negative 7 minus 5? Negative 12 divided by 6? Negative 2, another rational number. Oh my goodness, 2 rational roots. I got 2 rational roots, yay! Questions?
So we're finding the discriminant and use it to describe the nature of the group of the equation just to like touch on it?
No, that was that part. That's kind of like telling me what's going to happen. It's telling me what to expect, right? I'm going to get a 25 under the radical, and I should get 2 rational roots. So that's why I went back to compare what I said. Okay? Does that make sense? Yes, ma'am.
Is this also kind of how we did the AC?
Kind of. It's the same values. A, B, and C are the same in the same place as before. This is just different a little bit. Okay? Please look at number 3. Want to put it in the correct order? X squared minus 14x plus 58 equals 0. I want to identify my A, B, and my C. A is 1, B is negative 14, C is 58. Excellent. I want to find my discriminant. Somebody take out their calculator for me and press in these buttons, exactly these buttons. Negative 1, 4, squared. Enter. So negative 14 squared is negative 196. So is the calculator lying to you? No, it's not. It's telling you exactly what you asked it, right? You said to the calculator, please square 14 and then multiply by negative, because the calculator does order of operations, right? If you truly want negative 14 squared, like you said, put the negative 14 in parentheses. Or, as pre-AP students, what? Just know, when you square a negative number, you're going to get a positive, right? You might not know 14 squared. I happen to because math, right? I've done it for a while, okay? But if you have to put it in, either put the negative 14 in parentheses or just square 14 and know it's going to be a positive number because it's a negative number squared. Fair enough? Okay, 196 minus 4 times 1 times 58. What is 4 times 1 times 58? Two what? 232? Maybe? Huh. So what is 196 minus 232? Negative 36. Negative 36 is less than 0. So I should get 2 complex roots, right? So let's solve it. X equals negative b. Why? B's already negative. plus or minus the square root of b squared minus 4ac all over 2a. X equals 14 plus or minus 6i over 2. Can you go ahead and simplify that down? That's a good question. Yes, you can. Are both of these terms divisible by 2? Then divide them both by 2. 7 plus or minus 3i. Questions? Yes, sir.
Do you have to, so like we've already done it, but this didn't happen.
Uh-huh.
Do we have to write 7 plus 3i, 7 minus 3i?
No, no, no. You can write it like this. This takes care of both of those. That is your two solutions. Actually, I need to make sure you understand that. 7 plus 3i is one solution. 7 minus 3i is your other solution. We're just writing it because we're saving the environment. Remember? Not anymore because I just wrote it double, right? Do you understand that, though? Is everybody okay with that? Okay. Let me show you what I need you to do for homework first of all, and then we'll go back if we have time. On this back page, I need you to do 1 through 6. I need you to do 7a and 8a. Those are the only ones that I'm going to check, is 1 through 6, 7a and 8a, but I would really, really like you to try b and c on both of these on the bottom. Why am I not going to grade them? We haven't talked about them, right? Okay. I wasn't sure if we were going to have time. We didn't have time last period, and I didn't want to have you guys do something that they're not doing. Okay. Wait, when did we talk about A? 7a? I mean, I know, but when, do you guys know when we talked about it? What's another way to ask the question? What is the complex conjugate? Do you see that it's asking that same question? If this is one root, what's the other root? What is the complex conjugate? Does that make sense? Okay, so if we're doing this one, go back to the previous, on the sample questions, example questions, whatever. 4a, if it's 3 plus 5i, what's the other root? 3 minus 5i. If it's this one right here, on 5a, what is it? -2 minus 8i. Yes? Okay. Any questions on 1 through 6, 7a, or 8a? Anyone? Come by for tutorials if you need my help. Ask questions until the bell. Peace.